presentation, and there's my question to Professor Sparagano. What are the current research trends to control vector-borne diseases?
Thank you, Professor Richter. Thank you to One Health and Implementation Research for organizing this discussion today. I think we start with a conundrum questions because vector-borne diseases are so diverse. We could be talking about mosquitoes and malaria still killing 1 million people per year. We could be talking about leishmaniasis in South America. So we could be talking about a lot of different vectors, mosquito, ticks, mites, flies. A lot of things are responsible for vector-borne diseases. And under vector-borne diseases, we could have a lot of pathogens because these vectors have found a way to transmit bacteria, viruses, fungus, and parasites. So it's quite something in terms of research. You can imagine there are hundreds and hundreds of colleagues working on this kind of research. And I think the word itself, vector-borne disease, is already telling us in which direction colleagues are working. We know that some colleagues want to work on the vector, and they can work in the vector in the environment, trying to block the vectors to proliferate, to continue their life cycles. Many years ago, we colleagues tried to release sterile mosquitoes, but it doesn't work very well, considering that sometimes the vectors we do research on in laboratories are not very good to survive in the environment. So there is a lot of work to be done there. And we have seen a lot of research groups trying to develop vaccines against arthropods and vectors with limitation in the number of successes. Some of us will remember the first tick vaccine in the 80s, 90s. But that was very limited to a number of tick species like the Bophilis microplus, now known as Rhipiphysalis microplus. And so far, colleagues working on malaria are struggling to develop a vaccine against mosquitoes. So we see a lot of difficulties but a lot of people researching now maybe on the vectors, because if we can block the mosquito, if we can block the ticks, if we can block the mites, then actually we try to block all the diseases they can transmit. And we know that some of them can transmit a lot of diseases at the same time. So one bite and you get a lot of pathogens in your blood. And so now some colleagues will decide, instead of trying to develop a vaccine against one parasite, one fungus, one bacteria, maybe let's try to knock down the vectors. I think now the research is going to be more integrated. We see colleagues now working more on that the vector is not a black box anymore. We want to know what's happening inside the vectors. For instance, the immune system of the vectors is not always very well understood. And we see a lot of colleagues now who are developing research on the microbiome of the vectors. And that's maybe the new fight. We understand that we are not always winning the fight against the mosquitoes, the mites, the ticks. And now we try to kill their friends, and their friends could be their microbiome inside their gut. And we see a lot of research now trying to kill their friends, or maybe to develop their enemies, like predators or pathogens that will make them unable to develop to the next stage or to be able to reproduce. So I think there are more questions than answer with your question in terms of where do we go with research. I think there is still a long way to go because we find a lot of drugs are now not working anymore in terms of resistance, and we don't have a lot of vaccines on the market, and we know that some of the vaccine will take between 5 and 15 years to go on the market. So there is still a lot of work to be done. But that is the exciting under vector-borne diseases. I see colleagues working on the host, the animals or human patients, or people working on the pathogens or the vectors. So we have job for a lot of people. If some more people wants to join the fight against vector-borne diseases and research, they are very welcome. Thank you for the question.
So you can say we can trust evolution, that we will not lose our work.
There's still a lot of work for everybody, and the vectors are also resisting and they are adapting. I mean, they have been there for a long time.